Welcome to the first video of week 4. So up until now we have got a strong foundation in Flutter. You know about the basics widgets, you know about the advanced widgets, you know how to deal with Firebase in Flutter, you also know how to build complex UIs in Flutter and so on. So in this video, we are going to talk about something that is very important for an application software to stand out in market and be maintainable, scalable, and also testable. So first, let's get started with the software. What is a software? At high level perspective, a software is broken down into two terms, soft and where the soft means changeable and the where means product. And it altogether means a software where the changes can happen easily without any hassle. And a software has two core values, behavior and structure. The behavior refers to its functional aspects like what it does, and the structure of a software on the other hand pertains to architecture and design. The architecture represents the high-level blueprints of system. It highlights a big picture, that how the significant component interact and align with the business objectives. And the design on the other hand often seems to imply the structures and the decisions at lower level. It's about the specifics that works inside the boundaries set by the architecture. And the software developers are responsible for making sure both the values remains high. But unfortunately, they often focus on the first value, which is behavior. They only make a software works. And even more unfortunately, they often focus on the lesser of the two values, leaving the software eventually valueless. According to Robert C. Martin in his book, The Clean Architecture, Craftsman's Guide to Software, Structure and Design, it does not take huge amount of knowledge and skill to get a program working. Kids in high school do it all the time. Yes, it does not take huge amount of knowledge to make a program work. It's pretty simple. As a stakeholder of a system software used to say, it's more important to make a software work. And developers in turns forget their responsibility. They often go along with the same behavior, focusing on the first value, which is behavior. They only make a software works and does not focus on the architecture. He further says, if you give me a program that is working fine, but the changes are impossible, you cannot add new features according to the requirements. So this program is totally useless. And if you give me a program that is not working, but the changes can happen easily, and adding new features according to the requirements does not make it a headache. So I can make this program works and use this program, and this program is continually useful. And one of the greatest thing that emphasizes on the second greater value of software, which is the architecture, in his book is the else-never matrix. It states that I have two kinds of problems, the urgent and the important. The urgent are not important and the important are never urgent. Same like this, the first value of a software, which is behavior, is urgent but not always particularly important. And the second value of a software, which is architecture, is important but never particularly urgent. So if you got a software which works perfectly fine but the changes are impossible, so this software is totally a mess. Because it's the characteristic of a hardware, we cannot make any changes in the hardware. For example, you have a motherboard of a system and you want to make changes in it. So you cannot do it yourself, you need an expert for this. And if you want extra functionality in your motherboard of your system, so you have to purchase another one, as simple as that. And this is same in the case of a software. If a software is not changeable, we cannot call it a software. It will be called a hardware, even though it's a software. We cannot call a software the software if it's not changeable, because a hardware is not changeable. That's the characteristic of a hardware, and the software is supposed to be changeable, and that is the biggest responsibility of the software developers. But on the other hand, if you got a software which is not working but the changes can happen easily, so this software is continually useful, we can fix it and use this. So this visualizes that we must focus on the first what's important for building a best software, and that is the architecture. The architecture is something in the context of high level, which is diverse from low level details. So when we say something in the context of high level, we refer something abstract, something general, or lots of principles and structures, the overall functionalities of a system, the major components and the interaction between those components. It's about understanding what the software aims to achieve and how the major parts came together to meet those aims. And the divorce in that context means that separated or detached. The lower level details are the nitty-gritty specific implementation details. This might include specific algorithms, data structures, communication protocols, and so on. So over the last several decades, we have seen so many architectural systems released into the market. These include hexagonal architecture, onion architecture, screaming architecture, DCI, BCE, and a lot more. All of these architecture vary somewhat in their details, but at a point they are very similar, carrying a single primary objective, which is the separation of concern. And to achieve such separation of concern, they divide a software into layers. This clean architecture is proposed by Robert C. Martin, who is so-called Uncle Bob. And the dependency rule of this architecture says that the source code dependencies must point only inward toward the higher level policies. The arrow you can see specify the dependency flow inward. This simply means that nothing that belongs to the inner layer can know anything at all about something that belongs to the outer layers. And to be more specific, the things that belongs to the inner layer should not reference anything like the function, classes, or variables from the outer layers. This ensures clean and distinct boundary between the layers. So now first, let's understand the clean architecture proposed by Robert C. Martin, and then we will understand the architecture that we will be using in our Flutter application, that is the TDD architecture or test-driven development architecture. So first, we will understand the architecture proposed by Robert C. Martin, and then we will relate the architecture of the Robert C. Martin with the architecture we will be using in our Flutter application, that is the TDD Clean Architecture. And then we will separately understand the architecture of TDD, test-driven development, and also create the project directories accordingly. So in this architecture, first we have the entities. The entities is the most independent layer of this architecture. The entities represent the core business logic. It's crucial for the whole enterprise. These rules stay consistent irrespective of application changes, and they act as foundational objects and maintains high-level rules. And next, the use cases. The use cases is the second layer of this architecture. This layer depends upon the entities, as shown in the diagram of the arrow of the dependency flow. The use case layer focuses on the specific application operations and how the data is processed within. It defines the data flow and utilizes the entities and their business logic, and it is shielded from the external tools. If the application operations evolve, this layer will be adjusted accordingly. Like for example, we have the use case of sign in, but if the stakeholders or the client says we also need the Google sign in, so a new use cases will be added, and this use case layer will be adjusted accordingly. And next, the interface adapters. This layer acts as a translator. It adjusts data formats between the application core, entities and use cases, and the external systems like database or web services. And lastly, the frameworks and drivers. Here we see the external tools and systems like the databases, web frameworks, etc. It's more about interfacing with externalities than the core logic. Its primary job is to communicate and relay the data to the inner circles or layers, treating the intricate, technical specific as surface level details. So after seeing this architecture, some people sometimes argues that you must stick to what the Robert C. Martin says, and some people argues that why we have only 4 layers? Can we have more or less than 4 layers? So Robert C. Martin answered this in his book The Clean Architecture, Craftsman Guides to Software Structure and Design. The chapter 22, the chapter name is also The Clean Architecture, and the topic name is Only 4 Circles. He is asking that can we have 4 circles or more than 4 circles or also less than 4 circles. So there he says that while the diagram showcases 4 layers, it's not a rigid rule. An architecture can have additional layers. It depends upon the specific needs of a project. The depicted 4 layers are the foundational guidelines. It's not a strict rule. But here you also need to keep one more thing in mind, that is the dependency rule must always be applied. And the dependency rule states that the dependency must always point inward. This ensures that The efficient business logic found in the inner layers remains unaffected by the external changes. The inner layer encapsulates high-level policies and abstractions, and the outer layers deals with the concrete details and implementations. By ensuring that the more concrete details depend upon the abstractions and not the other way around, the architecture maintains its integrity and flexibility. So, to be specific with Flutter, we have this clean architecture TDD test-driven development pattern which divides the software into three layers: presentation, domain, and data layer. If you have watched my previous course of Instagram clone clean architecture, you might be familiar with this diagram, but if you have not, there is no need to worry because we are going to learn and understand each and every little process from scratch. So looking at this architecture and relating it to the clean architecture proposed by our friend the Uncle Bob or Robert C. Martin, first we had the entities. First, the entities were the most independent and the inner layer which contained the high-level policy or the core business rules. And in the case of TDD, test-driven development clean architecture, the most independent and the inner layer is domain layer, which holds the primary entities and use cases and the repository contract. These domain objects capture the essence of the business logic, much like the entities in the clean architecture. Next, the interface adapters from the clean architecture relates to the data layer in the TDD clean architecture. The interface adapters deal with the data format translation, ensuring that the core system can communicate with the external system. And the data layer in the TDD architecture plays a similar role. The repository implementation serves the function of implementing the contract established in the domain layer. Further, the models in the data layer which extends the entities from the domain layer and bridge the domain high-level abstractions with the practical data structures and formats suitable for the external storage or API communication. Lastly, the framework and drivers is indeed outermost layer of clean architecture. Its main role is to deal with the more volatile and changeable elements. However, it's slightly misleading to club both UI frameworks like Flutter and backend details like database under the presentation layer in TDD Clean Architecture. In the TDD Clean Architecture, the presentation layer primarily refers to the UI and associated presentation logic, not the backend systems or external services, but backend stuff is handled in the data layer, which deals with the outside world. When the Robert C. Martin talks about the clean architecture, the emphasis is upon decoupling the core of the software entity's business logic from the volatile elements. By placing both the UI and database in the outermost layer, it underscores the idea that changes in technology, platforms, or user interfaces should not impact the core functionality and rules of the software. And the TDD Clean Architecture, we place our backend stuff where we deal with the outside world in the data layer and the UI stuff placed in the presentation layer. Both of them are the outer layers and are more volatile, and both depend upon the domain layer for the core business logic and rules. So now you might have a basic idea of the clean architecture test-driven development, that what each layer is responsible for. So let's understand this clean architecture TDD test-driven development a bit more in depth with the Flutter-specific and create the project directories accordingly. So the call flow goes from top to bottom, from widgets to the final implementation in the data layer, where we deal with the outside world logic, like the API's communication, any kind of backend like Firebase or the local data sources. In the presentation layer, there are widgets, pages, and the presentation logic holders, such as block, change notifier, mobx, etc. to separate the business logic from the UI code and manage the state of our application more efficiently. That layer is where we interact with our app. But in this architecture, the logic holders do not hold so much logic, but instead they delegate most of their work to the use cases in the domain layer, which visualize that the dependency flow from presentation layer to the domain layer and is inward flow. So in your Flutter project, inside the features, let's create the directories for the presentation. So we are going to have a presentation layer, and inside this presentation layer, we are going to have the directories of the pages, widgets, and also block, or you can also have any other state management solution. Next, the domain layer contains the core business logic. entities, use cases, and the abstract definition of the repositories. It's completely independent, meaning that it does not depend on any other layer, but other layers depend upon it. The use cases are the specific use cases of the application, such as the login with email, login with Google, forgot password, and send text message are the examples of the use cases. And the repository is a core contract interface, which holds the unimplemented use cases of the application, and to fulfill this contract, it's implemented in the data layer, where this fancy gradient of the repository comes into play. You might ask that I just said the domain layer is independent and it does not depend on any other layer. So what that gradient of the repositories between the domain and data layers shows up? This gradient represents the dependency inversion principle as we have learned it in the week 3. Instead of the high level domain layer relying on the low level data layer directly, both depend upon the shared abstractions. This way, the core business logic remains separated from the specific implementation details, ensuring the flexibility and maintainability of the system. So inside the Android Studio, our domain layer will look something like this. Let's create a directory for the domain layer. Inside this domain layer, we are going to have first the entities, the business objects, and then the use cases, the application business logic, and then one more directory that will be of repository. Inside the repository, there will be a contract class which will be fulfilled in the data layer. So here in the architecture, lastly in data layer, the contract signed in the domain layer is implemented in the data layer. Then it has the sources which could be local database or an API or any other data source. It contains the models which extends the entities, you will see it in the future videos, and have some extra functionalities in the models of conversion while dealing with the outside data. For example, while dealing with the Firebase, we need to convert the data from snapshot to dot objects and from dot objects to some JSON-like data to store it in the file store database. Or if we are dealing with any kind of API, while storing the data in the server, we need to convert it from the dot objects to JSON, and while retrieving it, we would have to again convert it from the JSON data to dot objects. So you might also ask why we have the entities and models separated. So that is because we want to keep the domain layer independent from any other third-party functionality. So in this architecture case, the models will be the subclasses of the entity classes, and these models will be located in the data layer and will deal with extra functionalities of conversion, like as I said, the conversion data from JSON to JSON or from snapshot to JSON. So let's create the data layer also inside the feature. Let's do it with the data, and inside the data we are going to have the directory of repository. Inside this repository, there will be the repository implementation which will fulfill the contract signed in this domain layer. And then we will create one more directory. Its name will be models, and lastly the data sources. Inside these data sources, we can have either local data source or remote data source. So that is what a single feature structure is going to look like, and we also discussed their dependencies. So let's create one more directory in here that would be the user, and inside this user, collapse this data, domain, and presentation, and move all of them to this user. And like this, our user feature will look something like this. And for the further features like chat, call, status, all of the features will going to contain these 3 layers and these directories inside these layers. So to understand the combined workflow, let's take an example to clear up how call flow will happen when single action is taken in our application. For example, a button is clicked by the user to sign up to the application. So first, we will directly discuss the things in this video. And in the future videos, you will practically see how a specific task or use case completes its job when it's triggered on the outermost layer, which is the presentation layer. So we will be interacting with our application with the outermost layer presentation, and a button is clicked. The call flow goes from widgets to the presentation logic holders, and from there they depend upon the use cases. So the specific use case of signup utilizes entities, in that case the user entity to sign up, and that use case depends upon the contract repository to do that specific job, again in that case the signup. So till now the call flow came from presentation to domain layer, which clearly shows up presentation layer depends upon the domain layer, and then that repository is implemented in the data layer. So here this again shows up the data layer also depends upon the domain layer for the repository by following the dependency inversion principle. And then that signup method in the repository implementations work with the remote data source, and this remote data source now utilizes the models for the necessary data conversions. And lastly, the actual logic is triggered in the data source of remote data source implementation and the action is performed. This will become more clear to you when we practically deal with the specific use case in our application, and later in this week 4 and 5 everything will become clear to you about this architecture. That's all. Along the time, when we implement the features of our app using this clean architecture, you will become more familiar and comfortable with this architecture. And later you can adopt this architecture in your production apps to make them easily testable, maintainable, and scalable, because that is what we want from an architecture. So that's all. See you in the next one.